Hello, I'm Brant Seitz.
I'm Henry Maloney.
I'm Tanner Balance.
And today we'll be presenting to you how to simulate a golf ball impact. We'll be doing this in two different ways. One, we'll be demonstrating how to do it on SolidWorks using a drop test, and two, we'll be showing you how to do it using ANSYS Explicit Dynamics. So just a little bit of background on the project. You'll see these two GIFs here. This is kind of what led us to this idea initially. We saw both of these on the internet and thought they were pretty interesting, and that's what led us to this idea. So we'll go ahead and jump right into it, and we'll first demonstrate how to perform a SolidWorks drop test. Of course, with any drop or any test in SolidWorks, the first step is creating your model. For us, we downloaded an accurate golf ball model from the internet, but it didn't have a core in it, so we had to modify the model a bit and include the core of a golf ball. And as you might imagine, we also needed to define our materials. However, SolidWorks doesn't include the materials we needed to define the golf ball. So we'll also begin by demonstrating how to create new materials in SolidWorks and apply those to your model.
Okay, so in this model we have two different materials, the core and the shell. The shell is made of custom material as the core is also. Open up the material library. You can see these custom materials that we've created. The Surlyn and the polybutadiene. These are the standard material models. This is what you normally see in SolidWorks. Now, you'll notice custom materials. Now, if you try and make a custom material under custom materials, that doesn't work. You'll see here we'll create a new material. Go change one of these values to 1000 and save. Nope. Temporary location doesn't work. Where'd it go? It disappeared. So don't do that. Instead, what you want to do is create a new library. And then you can go and define where you want to put that library. I'll put it on my flash drive. And this will save a material library that is only accessible to you. And once you do that, come back over to your new library, make a new category. Call this test 1. Then we can create a new material. And then this should work because we have it saved to a flash drive. So here we can edit all of the standard quantities: elastic modulus, Poisson ratio, shear modulus, mass density, tensile strength. All of these can now be adjusted. We can add a description to this material, name it. There's multiple model types. It's not elastic, linear elastic behavior. They have other models to choose from as well. So that's basically how we create a new material. And we can apply it, and now we'll see that the ball's core is our test material we just created.
So after creating your models and defining your materials, you can now begin the test. So go to the Simulation tab and click on New Study. From there, you'll click on Drop Test and give it a name, and then just click OK. Next, you'll see on the left a lot of the same options you're used to seeing from different simulations. You can expand your parts and make sure they're all there. Then you'll want to create a mesh. That'll be the first step. So click Create Mesh. And then you can specify how coarse or fine you want, as well as other features. In this case, we'll select a curvature-based mesh, and this helps with a lot of fine details like we see around the dimples. and then you'll click OK. After a while, you should see it generate your mesh, and it should display your mesh on your model, which you'll see here. This is a good point to check to make sure it has all the features you want and seems reasonably fine. Next, you can start to set up your actual drop test. So in order to do that, the first thing you'll want to do is right-click on Setup and click Define Edit. In this case, we're going to specify a velocity at impact instead of a drop height. What you'll want to select here is what reference plane you want the velocity to be referenced from. So we'll select a horizontal plane from the shell of the ball, and we'll input a velocity of 41.75. Next, you'll want to select a reference plane for gravity. It won't let you select the same plane you selected for the first one, so in this case, we'll select the top plane for the whole assembly, and then we'll define what direction we want gravity in, and it'll show you your arrow on the screen, and then after you've defined that, just click OK. The last step is just to click Run this study, which you've probably done with other simulations, so go ahead and click that, and then you should see a window pop up that displays the progress of the test. And with the drop test, like any other test, your run time or calculation time depends greatly on how fine your mesh is, what kind of parameters you inputted when you're setting up the test, how complicated your geometry is, a number of different factors. So our suggestion and what we did was to start with pretty simple geometries and pretty coarse meshes and see if your results are reasonable. So after a while, it will generate your results, and you can go click on stress and right click and click show, and it'll display your stress results as well as the ball in its deformed state. Same thing for displacement. You can right click and click show, and it'll show you your displacement results, and the same thing for strain. In this particular test, we kind of got some odd results. I think part of that was due to how we set up the mesh for this test and the parameters we specified at the beginning for the drop test. So as we were kind of saying earlier, it's good to start small and start with simple geometries and coarse meshes and work your way up until you're confident that your test is running correctly. So that's how you perform a drop test. So after running your test and obtaining your results, another important step often with running these SOLIDWORKS tests is viewing your results in a convenient manner. One of those might be animating your results. So here we'll demonstrate how to animate your drop test and save that as a video file.
Now we are going to animate a SOLIDWORKS drop test. First, right-click the stress results and show them. This is what we'll be animating. Next, right-click the stress results again and select Animate. SOLIDWORKS opens the animation window and begins to initialize the animation. And there's the animation. SOLIDWORKS will save it in the current view, so orient it as desired. In the animation window, you can speed up or slow down the frame rate. And you can also choose to loop the animation. In order to access those options, you must stop the animation. Now you can choose which frame the AVI starts on, which frame it stops on, the number of frames it increments by, and the number of frames before impact. SOLIDWORKS hasn't saved the AVI yet, so you must checkmark the Save as AVI file box. Select View with Media Player. You're going to want to click Options and select a compressor. We'll leave it as uncompressed. And find a file to put the AVI and give it a name. We're going to save it to the desktop as test video. Okay, and now we have to initialize the animation one more time by pressing play. Do not press OK yet, press play. SOLIDWORKS will reinitialize the animation and confirm that an AVI file has been created. And there you have it. The AVI has been created and saved. Now press the check mark to exit the animation window, and you're done.
Now that we have shown you how to run a SOLIDWORKS drop test, we will share with you some of our own results. On the far left is an actual golf ball being struck by a golf club. In the middle, we have our animation of a golf ball impacting at 41.75 meters per second, a speed typical of an average golf swing. On the far right is our displacement graph of our simulation. As you can see, our simulation is reasonable, but would benefit from being ran with finer meshes. Now we will walk you through running the same simulation, but in ANSYS Explicit Dynamic Simulation.
Okay, so this is the ANSYS Workbench page. This is what will happen when you open up. This is how you create a new standalone system. If we go into the engineering data, that is where we can create our new materials. Here we have the Surlyn and polybutadiene, can edit all their properties. And then if I'm doing another model, I can just drag and drop and share that data to the new model. Geometry can be imported. Just right click. You can import SOLIDWORKS file types. You can import IGES files. It's pretty universal. It'll convert almost anything. If we open up our model now, we should see our geometry. There it is. We've got a ball and a wall. And then from there, inside that geometry, that's how we define our material types. We could come down here and choose another material if we wanted to change it. And then if we come down to the mesh, this is where we create the mesh. You can see in the window here, that's the current mesh we're using. Some adjustments here can be made. Your relevance, that's just kind of on a slider bar from 0 to 100. Sizing, it's your size function. I use an adaptive size function. Here down at the bottom, we have statistics. You can see we have about 84,000 elements in this model. There's also other adjustments, advanced, whatever else. I don't mess with those. You can also insert controls here if you want to control the size or method. Kind of an easier way you can add that. Here's the model. You can see it's using the AutoDIN solver in this case. Here's the analysis settings, initial conditions, velocity. We have 20 meters per second going straight into that wall. That's how we define that. We go to our analysis settings. Here's the step controls. That's important for solving. These are what I basically tuned until it works. Euler domain, damping, erosion controls are kind of cool. That's if you are having kind of destructive behavior, how will material leave the model. And then output controls, that's how you want to save data to create your images and animations and such. Fixed supports, I have the sides of this wall fixed. And we do that by right-clicking, and then we can add a fixed support or other supports that way. If we come into the solution, we can see it doesn't really tell us a whole lot. Information, that's how many cycles, times it's run through. Here's our deformation solution. If we want to create a stress or strain or whatever, we just right-click on solution, add it there. Here's our deformation solution. Play this quick animation. And we can see that's the results it got. It did about 17 steps, I think. We can move it around. We could even get rid of that wall if we wanted to. But yeah, that's basically how it works. Then when we're done with that, we can come back to this main page and then make another model if we wanted to.
All right, now that we know how to model and simulate in ANSYS explicit dynamics, here are the results obtained. On the left side, we can see the mesh of both the ball and the wall it impacted, and on the right is the animation. For this study, only the core of the golf ball was animated, or was modeled, and in the future, we'd like to run this simulation for a longer amount of time, and we'd like to model the shell as well. And with that, are there any questions?